Okay, perfect. Time. Hello, everyone. My name is Vighnesh, and I'll be presenting SimCommand, a high-performance RTL Testbench API with fork join support. This is joint work with me and Youngjin. So, after we write RTL, the first thing you do, I hope, is you write a test bench for it. And so to make this productive, I think hardware designers really love having these things, like a good standard library in your host language, a package or dependency manager, unit testing library, and ideally an IDE. And so how do these stack up in our various ecosystems? So we have like the Verilog ecosystem, you have FuseSock as a package manager, like vunit. In C++, you have like a nice standard library. You have CMake and CLion as your build tool in IDE. In Python, it's probably the best possible case. You have pip, PyTest, and PyCharm. These are all great. And I think what this tells us in general is while Verilog is okay for writing test benches, a lot of us really prefer to write test benches in a general purpose programming language. That's what gives us the best productivity. So what do these testbench APIs look like in general purpose languages? So we have Chisel Test in Scala and the very popular CocoaDB in Python. And they're both very flexible and easy to use. They provide all the benefits of being in a general purpose language while having these fork join primitives, which we use all the time in our tests to emulate testbench parallelism. However, their fork join functionality is slow. And my case here is we shouldn't have to compromise on performance in order to have the utility of a high-level programming language. And so what is SimCommand? It is just a testbench API that is embedded in Scala. It uses Chisel Test as a simulator interface, and importantly, it's purely functional. So the testbench description of what you want to do and the actual interpretation of that are split. So here's a function to like enqueue some data into a FIFO, and this just returns a description of what to do. It doesn't actually perform the action. And here's an implementation of how you might fork off two different threads. So here enqueue, I enqueue 100 into a queue. I also dequeue. I join on those threads and I assert that, oh, what I dequeued must equal 100. And then when I actually execute the test, I call run on this command, giving a clock, and then I actually execute that the things that go on inside that command. So this split between interpretation and execution is what allows us to do a very high performance fork join. So how does it work? You have like your interpreter scheduler runtime looks like this. You like have a fixed point iteration on every time step, and then once you do that with every single thread, you step the clock and you repeat this until you have a return from your main thread. And what does this give you? You get a lot of performance benefits. So Chisel Test now with this command API can do a lot better than Chisel Test with fork join or CocoaDB on these two benchmarks. And you can see in some cases, Chisel Test with a command API can even outperform the commercial simulator because of some very special optimization tricks that I can talk about if you're interested. So it's faster. You can write system-level tests now using Scala, and the ideas here are applicable to other host languages. There's some more stuff here, and if you're interested, check out our GitHub repository. So thanks.